हाँ
Okay.
हाँ
Yeah. Good evening, viewers. This is again Professor Banerjee back to the technical this session, this YouTube session number 3. And in session 2, what we discussed, that actually mostly it is on the board behind me, and where we try to give a sort of, that the overall water supply and this wastewater management system, water supply system as well as wastewater management system, and it is sort of a loop or so that I try to sort of discuss this way, so that it is a loop. And if you have seen or if you see by that session 2, this YouTube session also 2, you have understood or you will understand, you will be able to understand that the discussion part what we have had. So that part actually, I hope that I believe that you have understood. Now in session this 3, that means this session, what we will do actually, that means keeping reference to this, that the flow diagram, where we mentioned that how the water supply system actually, is planned, designed and executed on the field, right? So this is, you see that the intake works also, and I am not repeating this one. Now here we should mention that this water, what would be the amount of water, okay, the quantity of water which needs to be, drawn from the water supply source, which has been, selected based on certain criteria. That means that when we will select the source of this water, particularly the surface water source, so that actually, when the selection is over or so, then how much water is to be drawn from the surface water, so be it river or reservoir or stream or whatever it is. Now this actually, how do we calculate this, right? So I am erasing this wastewater part now. For now, I am just erasing this one. This we will discuss later. So as you see here, please ignore the pink color, this one, because this we actually discussed in the session 2, that was related to the sewerage system also. But here this is the water supply system also. Now what we do actually, first we have to understand that water, demand. Water demand. So this water demand, you see that this is the basic need. So that is to be, addressed also. So first one is the domestic need, such as, the drinking, cooking, then bathing, washing, flushing of toilet, gardening, so etc. Maybe some other need also there, domestic need. Now this actually while this is the domestic need also, the second, this one is the institutional need. The third one is the public purposes, such as, street washing in case of urban area, means urban center also. Then the other, this one, like that, flushing of sewage, then watering of public parks, etc. Right? So these you will get in the CPHO manual. And let me here point out that, okay, let me complete this part, then I will go back to this. Now, this is collection of water, treatment of conventional treatment of water treatment, distribution, and about the pipe distribution, the network also, that already we have discussed, so I am not repeating this here, right? So, the other needs will be, that the industrial, to continue this here, right? So, fourth one is industrial and commercial usage, industrial and commercial uses. Then that, including AC system, cooling system, etc., etc. So we are not going to that details. Now, fighting others. Then requirement for livestock, and seventh one is the you can say that rather maximum permissible unaccounted for water, or in other words you can say that wastage, leakage, etc. So if we see that this the water demand, so when you will plan or subsequently design a water supply system also, you have to consider all the needs, domestic needs, then this institutional, commercial, for minor industrial, this one, and for major industries the separate calculations may be required. And here all these details you will get, that this is the manual CPHO manual on water supply and treatment. So CPHO means central, public health, and the EEO means, that is the, I'm writing this one here. So I'm erasing this one, keeping this flow diagram so that you can always understand that how the things go. So this is the erasing this, as it will always remain if you just go back while watching this video. You will get all these things, because these are going to remain on your YouTube video. Now this, that there are manuals, and I will recommend that each one of you download this manual. So this is the manual in CPHEEO, CPHEEO. So this is manual, and there are number of manuals. So this is the what I have shown. Just this is the water supply and treatment. Also operation maintenance, that also is there, but basic manual what I would recommend to use on regular basis also while pursuing this course on you are reading this and trying to learn this. So what is CPHO? What I was trying to say, that is Central Public Health and Environmental Engineering Organization. This is actually under, under Ministry of Urban Development. Right? So this is CPHO. And CPHO also has got this manual on sewerage and wastewater or sewage treatment, let us say. Sewage treatment. Right? And also there is a third manual also, that is on solid waste management. See that the wordings may little differ also, because I don't remember exactly what title they have given also, but water supply and treatment and this sewerage and sewage treatment, and the third one is the solid waste, maybe hazardous waste also they have added in the latest, I don't know, I don't remember that one rather. So solid waste management, so these three manuals, these are there, and these manuals what I have shown that on water supply, so similarly that the sewerage and sewage treatment manual also you will get. Apart from that, you see that when you will, consider that or estimate the demand of water. So in that case actually you see that the water supply and this water supply in buildings, that is there, right? And then is the quality requirement. So mainly CPHO manual, that will be there. Then requirements of water supply, that is IS code also. That is you know that Indian standard this codes, which is other Bureau of Indian Standards, Government of India. This is also Government of India, as I have already mentioned. So this is for the IS code, IS 1172. Here maybe, here what I have got in my hand right now. So that is 1971. This has been updated in subsequent years or so. It all the IS codes and manuals keep updated. They get updated periodically also. So this is all about the water supply. This one, requirements of water supply. Water supply, drainage and sanitation. So this is 1172. And here you see that you will get that for different, water supply in residences, then other than residences that will be there, and different, that hostel, then hotels, offices, factories, hospitals, schools, cinema halls, and all these actually will be available here. So based on that actually we calculate or estimate the demand also, water supply demand. And here let me tell you one more thing, that is normally you see that normally what we do actually, we take this water requirement, right? So this is number one is the, you see that in first is the metropolitan cities. Metropolitan and sometimes mega cities also. The demand is that where sewerage system that is there and the piped water supply system both are existing also. So there the demand is 150 LPCD, that is liters per capita per day. So this is the the demand for metropolitan and mega cities also. Second is that cities with, I am not elaborating because this will take time, cities with water supply, piped water supply system, that is piped water supply system, where proper sewerage system is existing also, but it is non-metropolitan or non-mega cities also. So in that case, this is taken 135 LPCD. This 150 sometimes may go as high as 250 also, right? Depending on the nature of the city also, and it's it's grade of the city also. So that is there. These are all for Indian cities or Indian urban and rural areas also. Then towns, mid-level towns also, that is actually provided with water supply, but without sewerage system. So that is actually 70 LPCD. Where this is again, let me tell you that this is piped down with piped water supply system, but there is no sewerage system for collection of the wastewater also. In that case, the demand will be 70 LPCD also, and also in urban areas also, right? In small peri-urban or urban areas also, where water is supplied through public stand post. That means you might have seen that in some very small town also, municipal town also, there is a sort of that stand post is there, and there is a tap here, and this is the so in that case actually this is the stand post. So there actually this is 40 LPCD also, and of course without any sewerage system also. So this is the these are the demands for various types of cities also. So these are the demand also, and these demand that normally what we take for a big not very big city also, like metropolitan or this 135 we consider there, and accordingly we suppose are designing also. So what you have to do, you have understood that what depending on the type or nature of the city or so, you take any, say 135 LPCD, we are sort of planning the water supply system also. So in that case, how do you calculate this one? I mean here, and this also, consider the institutional or this is the domestic demand also, institutional plus commercial also, industrial, so that will come separately also, and separately to be calculated also. Now this 135 LPCD, what we do actually, we see that the population, because this is per so much of liters, 135 liters per capita per day. So the daily demand, if we see, so this will be, if we consider the daily demand, then we have to see the projected population into this 135. So this will be giving you the per capita that actually will be withdrawn there. So much of liter per day daily demand. So let me omit this part. So this is 135 liter total, this one. Now question is that projected population, how do you get this projected population? For that actually we need to the design period. That means for how much duration also a particular water supply system is being planned and designed and to be commissioned also. So design period will be used here and will be important. Design period normally varies 25 to 50 years or so. Usually we take for our design purpose, that is 30 years or so. So suppose today's population, that is something, this one, say P, if we say that the present population, right? P present. Now after 30 years or so, what would be the projected, this one, or futures, if we make a difference between the two. This is the present and this is the future also. That means after 30 years. So what would be the population, projected population, right? So there are some methods when we will discuss about the details of the water supply system and its design also. Then we will discuss about this, that the design period for different components. It has got a sort of a reservoir, say water treatment plant is there, then the water supply conduit is there, then your valves, fittings, the mechanical this equipment also there, these are there. So for different components, different design periods, these are given, and you can get in the CPHO manual what I have already shown to you. So design period usually we take 30 years or so. If otherwise it is mentioned, that one, if not mentioned, then it is 30 years or so. So you get that this after this population for that actually you have to design. So here this projected population, this will be future, means here let me change this that notation or the symbol also. Here we can say this is PP means the present population, say P, and this is the P projected, this one. Let us say P present, then it will be more clear, right? So this is the projected population. So based on that we calculate this, what is the domestic demand, that will demand for the population after 30 years or so, for which you are designing your system, water supply system. Okay. Now to that you add different institutional need or so that I have just I have shown 1172 IS code. So this actually speaks about the that I mean water supply, that 1172 what I have just given. Okay. Now this this demand, and there are some methods by which you can calculate the projected demand. I am not going to that to that extent today, because this is an overview. I am trying to give a general or an idea about the water supply system, how to plan this, how to design all these things in a very nutshell, and I am trying to give an overview as I have already told. So this is the water demand regarding that, and then to that you can also, as I have listed, so these demands also you can add on to get the total demand of the city or the town also to be supplied with water, piped water supply system. Okay. Now then what we do actually, this is institutional need, this 1172, then firefighting demand, that, and here actually you can have IS 9668, that is the firefighting, that is you can check this, and also industrial water demand from CPHO manual that is given, or otherwise you can also you can also refer, or we can also consult with the various IS codes, or particularly CPCB, Central Pollution Control Board, this under Ministry of Environment and Forest and Climate Change. So there you will get that one. So we will come later with this all this detailing also. Now in water supply system also important thing is that that the pressure requirement. Pressure requirement. Now you see that from the here water treatment plant, it is going to the distribution system. Now this here, please note that I am erasing this one, right? Now here, if you have got a reservoir also, right? That means through or via reservoir, that actually is going to that one. That means from here and from here it is going like that. So this is the elevated water reservoir, right? So this actually why it is done, because the treatment plant may not always continuously send the water supply to the consumers. Say 3 times in many in our localities or many localities, what happens actually, it is not continuous supply. It may be intermittent, which is the normal or common type of this water supply system, intermittent. In that case, suppose in morning 2 hours, 3 hours, or in the noon time, say 2 hours, 1 hour, like that, evening time. So that way, so in that case actually, what we do actually, this is stored in the elevated reservoir also, and from there actually it is supplied. May be regulated intermittently or continuously also. So this is pumped here and then it is supplied through this one. So it may be, if I draw it separately, so this is maybe, the plan, if I draw the reservoir plan, right here. So here the water is coming, then going via reservoir also. It may also have, this is this, that means it is both ways, that means continuously, or this also through elevated reservoir, or continuously. So, three options are there. Either through reservoir or continuously to the consumer, this one, right? Or that it is, both are this parallelly. So this is the system for the water supply to the consumer's end or the distribution system also. So this is the pressure requirement. Shall I stop, Sanju?
No, you can continue
Huh?
for another 5 minutes.
Okay, another 5 minutes. So it is maybe that 5 minutes we may sort of require or rather we use this. So pressure requirement, this one. Look, for single story building, remember the furthest end of the distribution system. Suppose with respect to the treatment plant, this that one, where from pumping or that one that is there. So or reservoir. This is actually here you see that the farthest end is this one. So here the pressure that actually head wise, water head wise. So pressure requirement that is for to supply to single story building. So that is, that I think 7 meter or so. Let me just quickly check this one. 7 meter, and then 2 storied, that is to supply to 2 storied building. Story or storied, you may write this one. 12 meter and 3 storied buildings. So that is 70 meters. Okay. And for meeting of the firefighting demand also, this is boosted by fire engines also. That means in the water supply system, this is tapped. From that, it is boosted according to the requirements also to extinguish the fire, this problem. So firefighting, for that, it is from the main line, it is tapped, and pressure is boosted also, that this one. So what I am trying to say, that this 7 meter of head, water head, these are all in terms of water head, equivalent to water head, right? So this must be available at the farthest. And accordingly, you have to calculate that if you supply through reservoir, then what should be the height of the reservoir, considering this 7 meter here, and then the longest length of pipe also, the frictional losses. So that is the frictional losses due to pipes also, this length of pipe. Then also this is minor losses mean head losses, of course. This is minor head losses due to valves, fittings, vanes, etc. in the pipeline, etc. Many appurtenances or ancillary components may be there with which are integral part of the water supply system. In that case, actually, accordingly, the losses have to be calculated. Minor losses to be added, separately calculated. Friction losses to be calculated. And here, normally, that the Hagen-Williams and Darcy-Weisbach we use. That is the Hagen-Williams equation or Darcy-Weisbach equation, and sometimes also Manning's. But Manning's normally we use in sewerage system also. We will see this later. Manning's equation. So this actually Hagen-Williams is point. That is a. Let me erase this one just to have more space. So that is the velocity water through the closed conductor pipe also, that is 0.85. C, that is the Hagen-William coefficient. R, that is 0.63. S is the hydraulic gradient. This is the sewage berth, that is the, that Q is equal to F L V square by twice G D. Right, and the Mannings, if you write this side, so this would be velocity is equal to 1 by N r to the power 2/3 s to the power half. So these are the equations, hydraulic equation, which are used, to find out that the friction loss also, right? Friction loss. So these, when you will get in any, the standard fluid mechanics books or books dealing with the hydraulics, so they are actually, you will get this. But just I have mentioned here, the Hagen-Williams and Darcy Which berth, these are normally used for the water supply system and in the pressure system also, because this is the water supply runs under pressure. So that is why this is a pressure line. And Manning's equation normally, and there are other equations too, we will come with more details later. So that is for actually, that normally for open channel or the sewage system, the flow, sewage flow through the sewer line also. So today, that this one, and quality requirements we will discuss. Time is there?
You can.
Okay. So the quality requirements, I will rather recommend this one, some codes where you can get directly the quality requirements, which have to be, satisfied or compliant with rather. So there actually, this is. So first is the drinking water IS code. Number 1 is the IS 10500 and year is 2012 or so. This is the latest, I suppose, but if you can, if you happen to see the later version of that, you can download this one. This is for drinking water standard. Now for irrigation, this one, the standards for irrigation water, that is IS 11624. Again, this regarding year I will say the same thing. That is later version may be available from BIS. So this is for the irrigation water. And what we do actually, the source water, whatever be the source, we check that for certain parameters which are listed, essential parameters also. Here for irrigation water, if it is to be supplied to for irrigation purpose, then this. So we have to check these parameters and compare with the standards given here, right? And then we have to decide that what extent and what type of treatment that should be provided also. So this, while this is the collection part also, the raw water pumping, and water treatment part depends on the quality requirements also. What the qualities which are available for the water which is withdrawn from the river also, and then we have to compare this with the standards given, IS codes. And then in CPHU manual also it is given, but normally we follow IS codes more or less similar, more or less. So there we find out that what actually, or we decide that what should be the type of treatment and what is the extent of treatment that we decide. So let us stop here for today. Next time we will continue with this for sewerage and leftover portion of the water supply system. Okay, thank you. Thank you all for your patient hearing, and Sohini also.